Black holes don't live forever. No matter how massive, how violent, or how ancient they are, black holes are slowly dying right now. The reason isn't gravity, it isn't collisions. It's something far stranger. Quantum physics is quietly tearing them apart from the inside out. For most of modern astronomy, black holes were believed to be eternal. Once formed, nothing could destroy them. They consumed matter, light, even time itself. And since nothing escaped, nothing could make them lose mass. That assumption held until the 1970s, when one idea completely shattered it. According to quantum mechanics, space is never truly empty. Even in a perfect vacuum, space constantly produces pairs of particles and antiparticles that appear and disappear almost instantly. Normally, they annihilate each other before anything happens. But near a black hole's event horizon, this balance breaks. If one of those particles falls into the black hole while the other escapes, the black hole loses a tiny amount of energy. To an outside observer, it looks like the black hole is emitting radiation. This effect is called Hawking radiation, and it means black holes aren't just swallowing the universe, they're leaking away. That radiation doesn't come from nowhere. It comes directly from the black hole's mass. Every particle that escapes makes the black hole slightly smaller, slightly lighter, and slightly hotter. The process is unbelievably slow, but it never stops. Here's where it gets counterintuitive. The more massive a black hole is, the slower it dies. Stellar mass black holes take around 10 to the power of 67 years to fully evaporate. Supermassive black holes like the ones at the centers of galaxies can survive for 10 to the power of 100 years or more. That's a number so large, it barely fits into language. For comparison, the universe itself is only about 13.8 billion years old. However, the moment a black hole begins to shrink, the process accelerates. As it loses mass, its temperature rises. Hotter black holes emit radiation faster. Faster radiation means faster mass loss. What began as a slow leak eventually turns into a runaway collapse. Near the end of its life, a black hole enters its most violent phase. After trillions upon trillions of years of silence, it releases a massive burst of energy, possibly similar to a gamma-ray explosion. The death itself is sudden, no gradual fading, just a final flash, and then nothing. In the far future of the universe, black holes may be the last objects standing, long after stars burn out, long after galaxies drift apart, long after planets freeze and protons decay. When the final black holes evaporate, the universe could be left as a cold, dark sea of radiation and elementary particles, a state known as heat death. But there's a deeper problem hidden inside this ending. If black holes evaporate completely, what happens to everything they swallowed? Information about matter, energy, and quantum states is supposed to be conserved. But Hawking radiation appears random. If the black hole disappears, does that information vanish with it? This question is called the black hole information paradox, and it's one of the biggest unsolved problems in physics. Its answer could require a new theory that unites gravity and quantum mechanics. In other words, understanding how black holes die might reveal how reality itself truly works. Black holes aren't immortal gods of destruction. They're ticking clocks, and their deaths may define the final chapter of the universe.